Hi everyone, I'm Dr. Surjit Singh. This is Leetcode problem number 3, also present in Google's question bank. Welcome to the video. From a given string, we have to find the length of its longest substring without repeating characters. We will discuss 3 solutions and compare their time and space complexities. The first solution uses the brute force method. This involves 3 steps. In the first step, we find all the substrings of the given string. Next, we reject the substrings which have duplicate characters. Finally, we compare the lengths of all the acceptable substrings. The length of the input string is 9, we save it in n. We initialize the result to 0 and find all the substrings. We run a loop within a loop. The outer loop I goes over all the characters in the string, and the inner loop j goes from position I to the end of the string. When both I and j are 0, the substring is A. We call the function acceptable to look for duplicates in the substrings within I to j. In the function named acceptable, we define a set named chars used and save all the characters in the substring to this set. For this purpose, we start a loop x which runs over all the characters of the substring. In the loop, character at position x is stored in the set. Before adding, we check if the character is already present in the set, we return false. If no duplicity is found, we return true. Back in the main function, when both I and j are 0, the substring A is acceptable. If the substring has no duplicates, we compute its length, which is given by j minus I plus 1, and its value is 1. So the result becomes 1. In the next iteration of the loop j, the substring is AB, which is also acceptable. So the new value of the result becomes 2. We repeat 2 more iterations and the result becomes 4. When j is 4, the substring is ABCDA. It has a duplicate character, so the function acceptable returns false. So result remains unchanged. When I becomes 1, the value of j is also 1 and the substring is B. This is an acceptable substring. The length of the substring B is 1, but the result is already more than 1, so result remains 4. When j is 5, the length of the substring is 5. Previous value of result was 4, so result becomes 5. In the next iteration, the substring has a duplicate A which is not acceptable, so the value of the result remains unchanged. In all the subsequent iterations, either the substring is not acceptable or its length is not more than 5, so the final value of the result is 5. Let's discuss the time complexity. Main program has 2 loops going over n, so the function acceptable is called n square times. The function acceptable has a loop that runs n times in the worst case. Hence it is linear in n, so the overall time complexity is of the order of n cube. We have used additional storage to store all the characters of the substring in a set. Hence the working memory space complexity is of the order of n, which is the maximum possible size of the substring. But this cannot be more than the size of the character set m. Sliding window is an improvement over the brute force. We set up a window using 2 pointers. Consider the same string. We use a counter named count to store the numbers of times each character is present in the substring. In the beginning, the counter is empty and the result is 0. The substring is the character within the window defined by the left and right pointers. Left pointer starts from the beginning of the string and the right pointer iterates over all the characters of the string. In the first iteration, the right pointer is also 0 and the substring is of 1 character, that is A. Inside the loop, we perform 3 operations: raise the counter of the current character, move the left pointer in case of duplicity, and update result. Character at right pointer is A. As this is the first time, the counter of A is set to 1. As this counter is not more than 1, the left pointer movement is not required and the while loop is skipped. Old value of the result is 0, while the length of the substring is 1. So result becomes 1. In the next iteration, right pointer becomes 1. So the substring between left and right pointers is AB. As it is the first occurrence of B, its counter is set to 1. Since it is less than 2, the while loop is skipped and left remains unchanged. The length of the substring between left and right is 2, so the new value of result is 2. In the next iteration, right is 2, substring is ABC, count for C becomes 1, left is unchanged, and result becomes 3. When right is 3, counter for D becomes 1, the new substring is ABCD, there is no duplicate, result becomes 4. When right becomes 4, it points to the second occurrence of A, so its count becomes 2. In case of duplicity, we need to move the left pointer towards right. We enter the while loop and move the left pointer till the count for A becomes 1 once again. So we move the left pointer and it now points to the index 1 and substring contracts to become BCDA. The count of A is decreased to 1. There is no more duplicate, so we come out of the while loop. The length of the new substring is 4 and the result remains unchanged. In the next iteration, right becomes 5 and E is added to the substring. Counter of E is set at 1, which means there is no duplicate. Length of the substring is 5, so result becomes 5. When right becomes 6, the count of A becomes 2 again, so we enter the while loop and start moving left pointer. Left becomes 2, substring reduces to CDAEA, the count of B is reduced by 1, but the count of A is still more than 1. So left becomes 3, substring becomes DACA, count for C becomes 0, but the count of A is still more than 1. So left becomes 4, the substring becomes AEA, and the count of D is reduced to 0, but the count of A is still more than 1. Finally, left becomes 5 and the count of A is decreased to 1, so the while loop is terminated. The length of the substring is 2, so result remains 5. Next, right becomes 7, the count of C increases from 0 to 1. Even though this is the second occurrence of C, the while loop is not executed because in the previous cycle of the while loop, count of C had become 0. The length of the substring is 3, but the result remains 5. In the last iteration of the main loop, right becomes 8, length of the current substring is 4, so the result remains 5. When the main loop terminates, final value of result is 5. The time complexity is linear, even though there is a loop within a loop. The two pointers move independently from beginning of the string to the end. At no stage the pointers move backwards, and no character is processed more than once in either of the two loops. The worst case time complexity is therefore of the order of 2n, which is same thing as order of n. We require additional storage to save the counts for each character. There can be maximum n entries in this counter, which is the size of the string. However, it cannot be more than the size of the character set. Optimized sliding window is the best of the three. Instead of saving the number of times each character appears, we set up a dictionary to store the position next to the character for all the characters. The next position helps us to skip directly to the desired position in case of a repetition. Chars is the name of the dictionary, which is empty in the beginning. The left pointer is at start of the array. We loop the right pointer over the entire length of the string. Before saving the character in the dictionary, we check if it is already present in the dictionary. In the first iteration, the dictionary is empty, so the if statement is ignored. When both I and j are 0, the substring is A, for which the length is 1. Value of the result becomes 1. The character at the right position is saved to the dictionary. The value associated with A is the position next to it. So character A is stored in the dictionary along with the position next to it, that is 1. Next value of right is 1. The character at the position is B. As B is not present in the dictionary, the if statement is skipped. Substring is AB and its length is 2, so result becomes 2. And B is stored in the dictionary with the value 2, which is the position next to B. Next value of right is 2. Character C is not present in the dictionary. Substring is now ABC and its length is 3. So result becomes 3 and C is stored in the dictionary with the value 3, which is the position next to C. In the next iteration of the loop, character D is processed and the result becomes 4. Now right becomes 4 where character A is present, which is a duplicate and already present in the dictionary. Hence the if statement is executed and the left pointer of the window moves directly to the position saved in the dictionary against A, which is 1. So the left becomes 1. Note that the left pointer cannot move backwards. Now substring is BCDA and its length is 4, result remains unchanged. The value for character A in the dictionary is modified to 5, that is the position next to the current position of A. Next character at right is E, which is the new character. The length of substring is 5, so result becomes 5. Next we store E to the dictionary. The position after E is 6, which becomes its value. Next character at position 6 is again A. It is present in the dictionary, so left directly becomes 5. Substring contracts to become EA. Its length is 2, which is less than the previous value of the result, so result is unchanged. New value of A in the dictionary now becomes 7. Ability to immediately move the left pointer to its appropriate position makes this new algorithm faster than the previous method. In the next iteration, right is at position 7 that has character C. C is present in the dictionary, but its value is 3, which is less than the current value of the pointer left, which is 5. And left cannot go backwards, so its value is not left unchanged. The current length of the substring is 3, so the result remains unchanged. And C8 is stored in the dictionary. In the last iteration, the character F is processed and result remains 5. F9 is stored in the dictionary. The final value of result is 5. Let us discuss the time complexity. There is only one loop over n and each of the 3 statements within it run in a constant time. So the time complexity is of the order of n. The result and the 2 pointers take constant space. Size of the dictionary depends on n, which is the size of the input string, or m, which is the size of the character set. So the space complexity is minimum of m and n. This makes optimized sliding window the best solution of all. Thank you for your time. I look forward to your feedback. Please support my work by liking the video and subscribing to my channel. See you in the next video.